The second way that we can make epoxides is using a reaction we've already talked about, the Williamson ether synthesis. But this is going to be an intramolecular variation of that. So again, I'm going to use an alcohol starting material with a base like sodium hydride, but now I also have the organohalide, the bromide, in my substrate here. So let's see how this happens. If we take sodium hydride and break that apart, we get Na plus and H minus, which is the base. And then I'm going to draw out the bond to the OH, just so we have that to work with. So let's add that bond in. And we'll just erase the hydrogen that was on there. Okay, so what happens in this first step is going to be reaction of the base with the proton, and that will give us O minus. So from here, now what we have is our nucleophile and our organohalide in the same molecule next to one another. So this is an intramolecular SN2. The lone pair on the oxygen will come down here to form a bond, and we'll lose Br minus as the leaving group. And we're left with the epoxide. Now, in terms of stereochemistry, if you have stereochemistry in your starting material, like for example, let's say this OH was on a wedge, and I'll put this Br on a dash, that stereochemistry is going to be retained. So this oxygen will be on a wedge, and the epoxide will be on wedges. Okay, so pause the video for a second and think about how you could start with cyclopentane and the reactions from organic 1 that you would need in order to prepare this bromohydrin. How could you do that? Okay, well, there's not much that you can do with alkanes or cycloalkanes other than a radical halogenation. So I'm going to do a radical bromination. Do Br2 and light, and that will brominate. Now we have some functionality in the molecule that we can work with. Now, one thing that I'm going to go ahead and point out here that people will struggle with is the fact that this Br isn't the Br that ends up in the final product. You can't just easily add an OH to the next position. So instead, what we want to do is end up with an alkene, because if you have an alkene, you can add bromine and water to form the bromohydrin. So how do we get to the alkene? We take this organobromide and add a base to do an E2 elimination. So let's just add sodium methoxide. That's a base that will eliminate, and we get the double bond. Now that we have the double bond, remember from organic 1, you can add Br2 and water, and that will add Br and OH across that double bond.